Hello everyone. Today I am going to discuss quantum key cryptography and quantum key distribution. Before starting the quantum cryptography and the quantum key distribution, first I will define what is cryptography. So, with the help of cryptography, the coding and decoding of we can provide the coding and decoding of the secret messages. And the cryptography is the art of rendering a message unintelligible to an unauthorized party. There is an example where I coded some plain text into cipher text and converting this text into plain text. So, cryptography is a part of the border field which also include crypto analysis and the art of code breaking. After that, what is the need of cryptography? Suppose there are two persons, first and the second, and both person want to share some secret message over an insecure channel. So this channel is an insecure channel where person 1 and person 2 try to communicate or try to share some secret message. Okay, so what is the need of cryptography here? So this if so they can authorize, they can access your message, they can access your secret message. Okay, and that person has no authority to access that message. Okay, so cryptography provide the facility that we can communicate over any communication channel without this type of event happening. Now, next is what is the need of the quantum cryptography? So the problem of distributing the keys in the OTP is the one-time password, is overcome in quantum key distribution. Using quantum effect, we can distribute keys in perfect secrecy. So quantum cryptography is used for the key distribution in perfect secure manner, and the result of perfect crypto system is the addition of the OTP and the quantum key distribution, where classical cryptography relies heavily on the complexity of the factoring integers, and the quantum computers can use some sure algorithms to efficiently break two-day crypto system. So there are so many types of algorithms where we can break the crypto system. After that, we need to understand what is quantum elements. The quantum mechanism depends on two major elements of quantum mechanism, that is Heisenberg uncertainty principle and the principle of photon polarizations. So there are the two basic elements of quantum mechanism where quantum mechanics depend. First one is the Heisenberg uncertainty principle, and the second is the principle of photon polarizations. In the Heisenberg uncertainty principle, or it states that certain pair of physical properties are related in such a way that measuring one property prevent the observer from simultaneously knowing the value for others. In the second mechanism, that is the principle of photon polarization, and it tells that an eavesdropper cannot copy unknown qubits due to non-cloning algorithm. So here, who is eavesdropper? Eavesdropper is a person who can access your message, who can access your secret message, and that person have no right authority to access that message, and person accessing the message is known as the eavesdropper. In this slide, there is a basic overview of the quantum cryptography. So, unique property of quantum cryptography is the ability of two communicating users to detect the presence of third party trying to gain knowledge of the key. By using quantum superposition or the quantum entanglement, and transmitting information in quantum state, a communication system can be implemented which can detect eavesdropping. Okay, so using quantum cryptography, we can detect eavesdropping. We can detect the person who can access our uh, secret message without any authority. In the next point, the polarization basic is the mapping, and we decide to use for a particular state. For the measurement of that, we use the entangled period of the photon. Now, next topic is the quantum key distribution. So, quantum key distribution exploits the effect discussed in order towards eavesdropping. So, with the help of quantum key distribution, what we can do? We can expose the effect of eavesdropping. And the quantum key description enables two parties to produce a shared random bit string known only to them, which can be used as a key for encryption and decryption. Now, once again, I want to explain what is encryption and what is decryption. So, encryption is a process where we convert plain text into ciphertext with the help of some keys and with the help of some algorithms, whereas the decryption is the just opposite of the encryption, where we can convert the ciphertext into plain text with the help of some keys and the algorithms. So we can use the symmetric key or as well as asymmetric key in cryptography for encryption and decryption. So in the next point, if an eavesdropper used the wrong polarization basic to measure the channel, the result of the measurement will be random. So how can we measure? So it may be measured as a random basis. There are three main security protocols for quantum key distributions. So many protocols are there for the quantum key distribution, but the three main protocols are used there, that is BB84, P92 and the entanglement based. Okay, in this lecture I am only discussing BB84 protocol. So what is BB84? BB84 was the first security protocol that was implementing in the quantum key distribution. So whenever anyone asks you what is BB84, so is it a security protocol, and it was implementing in quantum key distribution. The key consists of bit that will be transmitted as the photon. All the keys consist the number of bits, and it will be transmitted as the photon. And each bit is encoded with a random polarization basic. Suppose two persons such as the Alice and the Bob talking on the telephone. So first person Alice chooses a subset of the bit and reveal which basic she used to encode them to Bob. Encode them to Bob or the other person. And the next person, other person Bob tells Alice which basic he used to decode the same bit. It means we are using the same key where we can encode the message or we can decode the message. So that key is the combination of the bit, and what is the bit? And that bit will be transmitted as a photon. So in quantum key distribution or in the quantum cryptography, we use the photon or we use the bits. In the next point, where Bob tell Alice which basic he used to decode the same bit, where the same basic was used, Alice tell Bob which bit he ought to have got. It means they are communicating and they are using the same process to encode or to decode the messages. Now BB84 protocol with eavesdropping. So if an eavesdropper Eve is a eavesdropper that was I mentioned the picture, tries to tap the channel, that will automatically show up in the Bob's measurement. In those cases where both Alice and the Bob have used the same basic, Bob is like to obtain an incorrect measure as Eve intersect Alice's photon, and she has to measure them with a random basic and send new photon to the Bob. and the photon state cannot be cloned. It means you cannot uh, create a clone of that photons. So if you are not cloning that photon, you are not creating any duplicate photon. This is somehow very much difficult to track messages of some other. So this is the merit. It means the merit or the advantages. What are the advantages of it? So it is nearly impossible to steal. So somehow what I say, if we are not creating the clone of the photon, it means that somehow it is impossible to steal. Detect if someone is listening. It means that someone is listening our secret code, secret message, our talk, then we can detect it easily, and this one is the very much secure. After that, we have some disadvantages or the limitations here. So bright limit is the limitation. This is somehow it is a costly. Signal is absorbed, noise increased very much, and is complete with the traditional networks. Okay. So there are the some disadvantages or limitations. That is the price limit, cost. Second is the signal is absorbed. Third one is the noise increase, availability, and the it have to compete with traditional networks. So what are the conclusion at the in the last? So quantum cryptography is a major achievement in security engineering. As it gets implemented, it will allow perfectly to secure bank transactions, secret discussion for government officials, and well guarded trades, secret for industry. Okay. Hope is there any issue? We can solve it through messaging, or we can solve it through comment box. So if you have any issue, if you have any doubt, try to message me. Okay. Thank you.